Hello friends, welcome back to Digitalk. So in this session, I am going to cover few very important and critical topics of WebLogic Server, which is mostly used when we do the troubleshooting in WebLogic. Okay, and these kind of problems we frequently get in the WebLogic servers. So what we are going to cover here is one is what is the stuck thread, second is the hogging thread, third is how to deal with your stuck threads and hogging threads, and the fourth one is thread dump analysis. Okay, so this is a bit large topic which is called the thread dump analysis. Okay, but I will give you the initial idea what kind of issues that we see in the thread dumps, how we do the analysis of thread dump, and I will give you some use cases so that you will understand it properly. Okay, so now very first thing, what exactly is stuck thread? Okay, so simple in a WebLogic server, we have multiple applications are deployed, right? The clients are accessing your applications. Okay, and your WebLogic server may have an integration with the database for the data, right, with the help of data source. Now, along with that, your WebLogic may have integration with some third-party applications. Okay, it could be for example, MQ server, IBM MQ server. Okay, or it could be any of the third-party application which your WebLogic server is calling. Okay, so that means your WebLogic server has dependency on multiple components like the MQ server for the database, for some third-party APIs or some other applications. Okay, so what happens when any request reach to your WebLogic server? It takes some time to process. Okay, depend on the what kind of application you have, what is the expectation from the application. Based on that, it takes some time for the processing. Okay, for some of the applications, the latency should be very less, so it will be executed in the less than of 1 second, or you can say sometime milliseconds. Okay, but sometimes we have some heavy applications or heavy jobs or reporting kind of applications. Okay, where we expect the time of the execution may get increased in the WebLogic server. Okay, so now when any request is getting executed in WebLogic server, that means it is going to take some time for execution. And every request which is get executed by the WebLogic, okay, it is handled by a thread. Okay, so thread means it is a small portion of your memory, a small portion of your CPU time, right? Because it is a request which needs to be executed in your operating system. So a thread is assigned to each and every request, and as soon as the request is completed, this thread will release to the system so that it will be available for the other request. Okay, so now how much time this thread is going to take to complete the request, it depends on the multiple factors. As I said, there could be a dependency on the what kind of application that you have, what is the expected time for completion of the request. Okay, so now the default setting of stuck thread in the WebLogic is 600 seconds, okay, which is 5 minutes. So now that means if some of the request which is getting processed in the WebLogic server, okay, if it is going to take more than 5 minutes of a time, then that particular thread is going to declare as stuck, right? Because it got stuck more than the configured stuck thread time. So if we say the default setting is 60 second, 600 second, which is 5 minutes, that we are expecting that every transaction should get completed within maximum 5 minutes of a time. And if it is going to take longer than that for the execution, then I am going to declare this thread as stuck. This is a problematic thread. This is not expected. And we have to understand or analyze that why it is taking such a longer duration. Okay, so now again, as I said, there could be a certain applications where we are expecting larger time, like we have some reporting applications where the execution at the database level is going to take a lot of time. Okay, sometime maybe 7 minutes or maybe 10 to 15 minutes or more than that one. Okay, so if it is the expected case, you need to increase this stuck thread max time. If you are expecting 10 minutes for some transactions to get completed, so you can update this stuck thread time to 1200 seconds. And where we update it, we update it in the WebLogic console. You go to the console and click on your servers, click on your server name. Okay, you have to do it for each and every server. And then inside the configuration tab, you will see a tuning tab. Inside the tuning, you will specify the time value for stuck thread, which is called the stuck thread max time. Stuck thread max time. Right? So it's very simple. Every request is getting executed in the WebLogic with the help of a thread. Okay, and if any of the thread is going to take a larger time, that means if any of the request is going to take a larger time, then it is going to declare as a stuck. Now it is possible that if a thread is declared as stuck, it may get clear after some time, right? Because if in our case the stuck thread time is 600 seconds, which is 5 minutes, okay, and maybe possible that some of the request is taking larger than this one. So but it is also possible that that request get completed after some time, maybe not in the expected timeline, maybe within some large time. For example, as I said, we have a stuck thread max time of 600 seconds. Okay, it could be possible that requests get executed and completed in the 650 seconds, right? So that means it took 50 seconds more than the configured stuck thread time. So at that particular moment, when it crossed the 600 second, you will see the stuck thread created in your system. But after 15 seconds, if it is completed successfully, you will see the stuck thread will be gone. It will be clean automatically, right? So this is the first case, which is called the stuck thread. Okay, and what one important thing what we have learned, it is also possible that the thread which has been declared as stuck, it may get clear automatically if the request which is getting processed by the thread may get complete, okay, after some longer duration. Now, second is the hogging thread. Okay, so hogging thread is a kind of an indication that your system is slow, and after some time you may see stuck thread in your system. Okay, so this is a declaration of your hogging threads, which indicate that there could be something wrong happening in your system. That means the requests are taking longer time for the processing, and it can be declared as stuck. Okay, so for example, if I say you are seeing 50 hogging threads in your system, okay, so that means 50 threads are taking longer time for the execution. Now, what is the meaning of longer time? Okay, so this longer time is automatically calculated by the WebLogic based on the historical execution of the request. Okay, for example, the 10 requests are processed, okay, within 1 second, okay, and the next 10 requests are processing in 2 seconds. Then next 10 requests are getting processed in 3 seconds. So that means the average time of processing the 10 requests is continuously getting increased, right? So your WebLogic automatically understand this, that the current execution of the request is getting increased in comparison with the earlier one. Otherwise, the expected one may be 10 seconds, right? So if this is a situation where internal logic or algorithms or WebLogic identify that the threads are taking longer time for the execution of some request which is supposed to be processed within less time, okay, it is going to declare the thread as hogging threads. Okay, now again, it is possible that it happened for a short duration due to certain intermittent reasons, and after some time, okay, it may come down to the back to normal. So what will happen in that case? This hogging thread will be gone, because initially for the some duration your WebLogic server identified that the requests are continuously taking longer time for the execution in comparison with the previous request, and now again it came back to normal, so it will automatically clear the hogging threads. Okay, so now what we have learned importantly here, if you are seeing the hogging threads in the system, it is indicating that there is a problem in the system. Your some of the requests are getting processed slowly, or after some time these hogging threads may convert into the stuck threads. So this is the stuck thread and hogging thread. Now how to deal with stuck thread and hogging thread? There is no way to do any kind of a operations in your stuck thread or hogging thread. There is no way to kill or stop any of the thread which is declared as stuck or maybe declared as hogging thread. You don't have any control over that one. What you have in your hand only, you have to look for your system, or you have to monitor the total number of stuck threads and hogging threads for a period of a time, just to ensure that if it is going up and coming down, going up and coming down like this one, so that means the hogging threads are creating in your system, but it is again coming down, or maybe stuck threads are getting created and it is coming down. So if the graph is like something like that, zigzag. Okay, so that means the threads are getting created, getting stuck or getting created, but it is also getting cleared as well if it is going like this one. Okay, so that means the system is consistent, it is working properly. There may be some problem because it is some threads are getting stuck or maybe the hogging threads are there, but it is automatically getting clear as well. And again, it is getting created and again getting clear. That means there could be some kind of a slowness in some of the third-party applications or integrated applications or maybe in the WebLogic itself. Okay, but it is automatically getting clear in small duration, right? So if it is the case where the graph is going like zigzag, okay, you can continuously monitor the count of a stuck thread and hogging threads. Okay, what is the pattern of that? Now suppose that if you see the pattern something like which is continuously increasing. So this is graph, and if you are seeing something like this one, initially the stuck thread was 10, then it get increased to 15, then it get created to 20 and then 25. So if it is continuously increasing, and similarly maybe for hogging thread, initially the hogging threads was 10, then 15, then 20, then 25. So if it is continuously increasing in the upward direction, that means there is a major problem, and after some time your system may get slow or your system may get hang because it is continuously increasing your stuck thread and your hogging threads, okay, which may create the problem after some time in your WebLogic server. So what you need to do in that case, the only solution, you need to bounce the services to clean your stuck threads or the hogging threads. And bounce, if it is in your production environment, then go for the rolling bounce. Okay, that means one by one. So bring down and bring up the first server, and then once it is up and running, then go for the second server, then go for the third server, right? And in this way, you can clean up the stuck thread and hogging thread. So this is the way only you can deal with the stuck threads and hogging threads. Now the question comes to how to do the thread dump analysis. Okay, suppose that the threads are getting created continuously, and we need to look out for the issues, and we have to take on the thread dumps, right? So how to look for the thread dump? How to do the analysis of the thread dump? Okay, so see, thread dump analysis, it depend on multiple factors. Where there are multiple kind of a patterns in your thread dumps, not a single pattern. Okay, I will post few more videos on this thread dump analysis. Okay, very soon. So the basic thing what we see in the thread dump, the very first thing, how we take a thread dump, we have multiple commands. The basic command, which is a very quick, that you can use JStack, which is a part of your JDK. You can run JStack -l, then you can give the process ID of your server, and then you can redirect it to the some file like thread dump 1.txt. And similarly, within an interval of 5 to 10 minutes, 10 seconds, okay, you can take at least 5 to 10 number of thread dumps. One is not sufficient. We have to take at least 5, minimum 5, but good to have at least 10 thread dumps. And the interval could be 5 to 10 seconds between each and every thread dump. That means first thread dump taken at 10, 15 and 20 seconds. The next one you have to take around 10, 50 and then 25 seconds or maybe 30 seconds. Similarly, wait for 10 to 15 seconds, 5 to 10 seconds, and take at least 5 to 10 thread dumps. Now, why we take multiple thread dumps? Why we take multiple thread dumps? The reason is that in the thread dump, we have the state of the threads, right? Your threads are processing the request. So your thread state could be running, or maybe it is active, it is stuck. Okay, there are multiple states of the thread. So when you run the thread dump, it could be possible that some of the thread was waiting to get the connection from some MQ system, or maybe was waiting to get from the database, or maybe some third-party API. Sorry, right? So when you take the first thread dump, and if it is showing you waiting to get the connection from the MQ or waiting to get the database connection from the DB, okay, so it may be expected, right? As soon as you have taken the thread dump, this thread may get clear because the request will get the connection from MQ or maybe it will get the connection from DB. It was for fraction of second when you have taken the first thread dump. So if you are going to take only one thread dump and if you look for that, okay, the request is waiting for the MQ, request is waiting for the DB, okay, it will give the wrong impression, right? So that's why we take multiple thread dumps in an interval of around 5 to 10 or 15 seconds of interval. So we look for the multiple thread dumps. If suppose that first thread dump is showing you one of the thread was waiting on the request from MQ. Then you can directly go to the thread dump 5 or maybe thread dump 10 and then again look for the same thread. Was it there as well? And was it there as well? So if it's the same thread which is there in the thread dump 1 and it is there in the thread dump 10 as well, which is almost there will be a difference of a 1 minute of a time. So that means it shows that this particular thread was running for a longer duration. At least for 1 minute of a time, it was waiting to get connection from the MQ. This is a problematic situation. There shouldn't be such longer duration to get the response from the MQ. And that's why it is also preferred to take the multiple thread dump. So one thread dump is not sufficient to do this kind of a analysis. Right. Now, this is the very first thing what we look into the thread dump or why we take the multiple thread dumps. Right. Now, inside the thread dump, there could be multiple situations. One of the common situation we see the deadlock. Deadlock in the sense thread 1 processing the request A and waiting to get the B. There is a thread 2 which is processing request B and waiting to get A. Right. So it is waiting to get A, which is getting processed by T1, and it is processing B for which your thread 1 is waiting. Right. So this kind of a situation can make your thread stuck forever, which is called the deadlock. Okay. So you have to look for the different threads in your thread dump. If we have this kind of a situation where one thread is waiting for something, and if other thread is processing that request and waiting for the thread which is getting processed by the first one, it is the deadlock. Okay. Now, second other very common problem in thread dumps, okay, which is called a locking. Okay, where one thread, okay, may get locked multiple threads. Okay, that means we have a thread 1 and which may be blocking your multiple threads T2, T3, T4, T5, T6 and T7. It may be blocking the multiple threads. Okay, so how to identify this one? So with respect to each and every thread, okay, we have a memory address assigned in the thread dump, which is in the form of like 0x0000, then F116256, something like this one. This is a memory address associated with each and every thread. Okay, so if one thread is locking multiple thread, okay, so you have to look for two things. The first is waiting to lock, this is string, and second is locked. So waiting to lock means the thread which is waiting to get locked and the thread which is get locked. So if one thread which is locked and multiple requests are waiting to get this particular lock on this particular thread, that means this is the problematic thread because multiple threads are waiting due to this one. Right. So what you need to do for that, you can do certain kind of a customizations. You can write a certain kind of a commands that I will also explain you or share with you as well in next few sessions when I will come with the realistic thread dump. Okay, and I will show you with the execution. So you can create certain kind of a command. Okay, where you can do the grouping on the waiting to lock, and then you can get the count. How many are waiting to get on this waiting to lock situation? How many threads are there? And count. Suppose that it is 400. Right. So that means 400 threads are waiting to lock. Okay. And in that case, you need to identify on which memory address all these threads are waiting. Okay. So as I said, so there could be a thread 1 with the memory address of something like 0000 F9012, something like that one. If this thread with this particular memory address are blocking, there are 400 number of threads. Okay. So that means you have to look for the stack trace of this particular thread, what this thread is doing, because this is a problematic thread and you have to identify what this thread is doing. If this thread is get clear, okay, your all threads those were waiting to get the lock will also particularly get clear and you will come up with a situation, come out from the situation. This is one of the most common scenario after the deadlock where one thread is locked multiple threads, or you can say multiple threads are waiting to get a lock on a single thread. So if you find out this particular thread, okay, then your problem will be solved. right? So this is the way how we deal with the stuck thread, and hope now it is very clear to you what exactly is a stuck thread, which is hogging threads, and then how we deal with the hogging and stuck threads, and then how to do the analysis of the thread dumps.